But years went on, decades went on. No one found such a theory that could explain the experiments with such hidden variables. So this became something more of a philosophical question. Most physicists didn't care very much until in 1964, John Bell made an amazing theoretical discovery. By looking at a variation of this experiment that I just told you about, he could show that in that case, the predictions of quantum mechanics couldn't be reproduced by any kind of theory based on hidden variables, however complicated. And when you think of it, that's really strange, because that means that when you measure on one of these particles, it's not so that you just reveal a property that is already there and measure. No, the quantum information about the state is in the full, entangled state of both particles. Indeed, very strange. And so thought the young John Clauser, who said, let's do Bell's experiment. Let's perform it in the lab. Perhaps quantum mechanics isn't right in that situation. Now, that was easy to say, not so easy to do, because with the existing lab equipment, you couldn't perform that experiment. But with collaborators, he came up with a variation of the experiment that could be performed, and he and the late Stuart Friedman went to the lab. They did it, and they found that quantum mechanics works also in this case. Now, there were loopholes. And one particular loophole that John Bell had been very concerned about was that of locality. That means that Alice shouldn't be able to send signals to Bob so they could sort of agree on the result of the measurements. And that was hard to exclude experimentally. But in 1976, Alain Aspect wrote a paper where he proposed such an experiment. And a couple of years later, went to the lab, performed the experiments, and guess, again, quantum mechanics rules. So why is this a big deal? Didn't we know that quantum mechanics works? Well, to explain to you why it's such a big deal, let's go back again to 1935. Here is another paper by Schrödinger, which he says, I would not call entanglement one, but rather the trait of quantum mechanics. So now, much later, in retrospect, we understand that in addition to the profound philosophical and foundational implications of the studies of Bell states, the experiments performed by Clauser and Aspect opened the eyes of the physics community to the depth of Schrödinger's statements and provided tools for creating and manipulating and measuring states of particles that were entangled, although they were far away. And physicists now started to understand that entanglement and Bell pairs is a quantum resource that you can use to achieve amazing new things.